Kiddos, here's video going through the notes that we've had for Cycle 1, which is all about points, lines, planes, and angles. This is in case you happen to be absent for one of the days, and we're going to talk through some of the materials that you would have gotten in class. So first off, we had a starter, and the goal was to practice solving some linear equations. Here we've got a variable on both sides. And to do that, I've got to combine like terms, and I've got to get the 5x and 10x onto the same side. What I'm going to do is I'm going to minus 5x to both sides. The reason I'm choosing to do that is to keep the x positive, because that'll leave me with 5x minus 12 on the right side and 7 on the left. Now if I want to get x by itself, I've got to add 12 to both sides, and that leaves me with 19 is equal to 5x. And again, my goal is to get x by itself. To undo 5 times x, we got to divide by 5. And we end up with 19 over 5 is equal to x. Next up, we've got the same problem with a bit of a twist. We got to do a little bit of distribution first. Not the only way to solve this problem, but this is one way to approach this. So if we do that distribution here, we got 3 times 2x is going to be 6x. 3 times minus 5 is going to be minus 15, and that's equal to 10x and plus 8. I'm going to bring the 6x to the other side, and to do that I'm going to minus 6x again. I'm subtracting the smaller one in order to keep the x value positive, although I don't have to do that. We get minus 15 is equal to 4x and plus 8. To get the x by itself, we're going to minus 8 to both sides. That gives me negative 23 is equal to 4x, and then if I divide both sides by 4, we get negative 23 over 4 is equal to x. And that was our starter. We had a document that you can find in Google Classroom going through the basics of GeoGebra, and I really recommend that you do that. It's also a video if you get stuck on pieces. But one of the things that we are developing as part of this is some kind of common vocabulary to use. So for the next few minutes, we're going to look at a whole bunch of geometry vocab and how we describe those and how we draw those and how we reference those mathematically. Okay, so let's start off with the word point, which generally we've been using for quite some time. Let's start with the image for this. We tend to draw this as some kind of a dot, and we label it with a letter. If I were naming this, I'd call this point A. And a point, mathematically, it's a location, and it doesn't have any sign. It might be nice if I could spell location. There we go. So you might talk about a point on a coordinate plane or a point in space. This doesn't have any length or width or height. This is just a single point, and we say this has 0 dimensions. In terms of a line, we're talking about a line that's, we normally say a straight line, but let's use a different word, maybe a straight path. And it goes on forever. It also extends in opposite directions. So we're talking about something that goes through at least 2 points and then goes on forever in both directions. And I'm going to say forever. So the way that we tend to do this is we'll label a couple of points. So we got A and maybe B. And through here, we're going to draw a line. We're going to put arrows at the end to indicate that it goes on in both directions. And then we label this in a few different ways. Way number 1, we could call this line AB, and the notation that we'd use for that would be AB with a line run above that. We could call this line BA. Since we're going on forever in both directions, it doesn't matter which way we call that. In the third way, sometimes we use just a single letter to indicate a line. So we often use lowercase. We often use cursive for this. So I might call this line L as a third way to name this. So segment is also a straight path. I like that terminology. I'm going to also zoom in so I can actually write legibly here. So we're talking about some kind of a straight path, and this one's going to be between 2 points. So if we're talking about the difference between a segment and a line, a segment is going to have a defined endpoint. In fact, it's going to have 2 defined endpoints. So we're talking about something that instead of going through points A and B, this one is just going to end at those points. It's all the points between A and B in as short a distance as we can make. We name this a couple different ways. We can call this segment AB, or we can call this segment BA. The line segment on top of this is important for naming this. This tells us what type of figure we're talking about. If I listed just AB without the bar on top, that would be talking about the distance from A to B. We'll talk a little bit more about that later. Next up, we've got array. So this is another straight path. It's our last straight path. And we're going to say that array is a straight path, and it has only one endpoint. So in the other direction, it's going on forever. And I'm going to say it goes forever one way. So graphically, what we're talking about is what we would basically draw as an arrow. And here we're talking about 2 points that we're going to use to name this. The difference with this one is that we have to name this directionally. We have to call this ray AB, and that means that we're going from A to B. The endpoint is A. Unlike a line or a segment, we cannot name this backwards. Ray BA would mean that we're starting at B and going to the left. I'm going to do that with a laser pointer. So we'd be starting at B and going to the left instead of starting from A and going to B. So I cannot name this way. I'm going to cross that out so we don't actually have that there. That leads us to talking about opposite rays. Opposite rays are 2 rays that have one endpoint and form a line. So we're going to break this up into three pieces here. 2 rays with one endpoint and make a line. We have some other things that are 2 different rays, like angles, that we'll talk about in a little bit. So I want to be specific. This is going to be different because this makes a line. So when we're looking at this, we might have B in the center, and I'm going to go A here, I'm going to go C here, and if we're making a line, that's got to be the arrows on both ends to show that it goes on forever. So our rays here, I'm going to start with B and go to the right. This would be ray BC. And then I'm going to start at B and go to the left. This would be ray BA. Next up, we got the word perpendicular. The next 3 kind of go together. They're related to each other. And anything that is perpendicular are 2 segments or rays or lines or any combination of therein that meet at a 90-degree angle. So I'm going to say 2 paths. I really like that word. So that's a line or a segment or a ray that meet at a 90-degree angle. So they make what we call a right angle, which we're going to talk about again in a minute. So visually, 2 things are perpendicular, if they look something like this. First thing you need to know is we use that box to symbolize perpendicular. It also means 90-degree angle. And then if we're going to name this, I'm going to use 4 points here. I'm going to call this A, B, and C, D. The way that we would describe this is to say something like line AB. I'm going to use my line symbol for that. And we're talking about ray CD. And the symbol we use for perpendicular looks like an upside down T. This symbol means is perpendicular to. So the way that I'd read this is line AB is perpendicular to ray CD. The next we're going to talk about is midpoint. So it's a point that breaks a segment into two. We're going to use the word congruent, but on here I'm just going to write equal. So two congruent halves. We'll talk more about what it means to be congruent a little bit later. So that means that if I am talking about the midpoint of something that's 8 units long, each half would be 4. We're going to get some different notation here as well. So if we've got A and then B, if M was that midpoint, we'd be saying that each half of this would be equal. The way we note this in geometry is we use tick marks. So I could say the tick mark here, and that means that the length of AM is equal to the length of MB. We use the equal sign to talk about the lengths here. If we want to instead say that these are two mathematically and physically the same thing, we use something called a congruent symbol, which sometimes has the same meaning as equals, and sometimes there's some really important differences. But here we're talking about two segments that are the same size and shape, and the line above that we're saying that the lengths of each of these pieces are equal. The differences there are really subtle and not that big of a deal for most of the stuff that we do this year, but I'll keep mentioning that. Perpendicular bisector. So bisector comes from, I don't know, it's either Greek or Latin or maybe both, depending on the way that these things come from. We're talking about two, and sect comes from the word that means to cut. We're talking about cutting something into two, and specifically two equal pieces. And if we're perpendicular, this is cutting a segment into two equal pieces with a perpendicular line or ray or segment. So if we're talking about a perpendicular bisector, I might say a path. I'll use that same terminology. So it's a path that is perpendicular to a segment at its midpoint. So what we're going to be looking at here, if we've got my segment AB, where M is the midpoint, and I'm just going to mark those as congruent so that we know what's going on there, we would say that line M is a perpendicular bisector if it goes through the midpoint. I'm glad I used M twice. And is perpendicular at that place. Next up, we got some angles. An angle is formed from two rays that meet at a common point. That common point we're going to call a vertex, which you guys should be aware of from doing stuff middle school, but we'll talk about that in a couple minutes. And then we got some classification of angles. So an acute angle is an angle that measures less than 90 degrees. Less than 90 degrees. So, for example, if we were talking about this angle visually, we can see that this is acute. This might be, I don't know, 71 degrees or something, and that would be an acute angle. Just so that we know. So if this is an A, I was about to label that another A, that we would refer to this as angle ABC, where the vertex, that point, is in the middle. And to talk about the size of this angle, we use this notation. The measure of angle ABC is 71 degrees. And since that's less than 90, this angle is acute. Okay, so same type of thing. Now we're going to talk about an obtuse angle. I like that I called this N without actually talking about that for acute angle. So an angle that measures less than 90 for acute, for obtuse, is an angle. I'm going to make it look like I intended to do that. That measures more than 90 degrees. So we might have something like this. Let's call this J, K, and L. And this time we're going to call this 111 degrees. So I'd name this as angle JKL. The K goes in the middle because that's the vertex. I could also name this LKJ. The order does not matter as long as the vertex is in the middle. And for the measure of this, we'd say the measure of angle, and I will go backwards, LKJ, is equal to 111 degrees. Because it's greater than 90, it is obtuse. For a right angle, we're going to go that same route and say an angle that measures exactly 90 degrees. You might also recognize this means that things are perpendicular, and that would be true. So if I were looking at an angle, and here we're going to call this X, Y, Z. We would name this angle XYZ or angle ZYX. I'm going to go backwards because that sounds fun. And we'd say that the measure of angle XYZ or ZYX is equal to 90 degrees. And the last type of angle we're going to look at here is called a straight angle, although we also have these lovely things called reflex angles. And here we're talking about an angle that measures exactly 180 degrees. You might also recognize that this is the same thing as opposite rays. So we're talking about if you had two opposite rays, and if we called this A, B, C, we could call this angle ABC if you really wanted to, and the measure of angle ABC is 180 degrees. And then finally, we got the vertex. The vertex is going to be the point where, you can call it kind of the center of an angle. It's going to be where the two endpoints meet. So where the endpoint of the two rays or paths. I'm just going to cross out the word where there. So I'm going to call this the endpoint of the two rays forming an angle. All right, and if something is not in question, so if we had angle A here, the vertex would be A. If there are not multiple angles in one thing, we can just call the angle by the vertex. So if this were, we could call this either angle BAC, angle CAB, or because there are no other angles here, we can call this angle A. For the ones that we did up above, we could also name those by the vertex because there's not any confusion there. So I could call this angle K, and I could call my right angle angle Y. Okay, here's the start. It's actually kind of in the middle of the vocab thing that we looked at a few minutes ago. And here you're asked to kind of use that vocab to make some sense of these terms. So let's name some stuff. So let's name some rays, and I'm going to name several. I might name ray GA, and that would be starting at G and going through A. I could also name ray MA, that would be starting at M and going through A. I could also name ray MG, and that would be starting at M and going through G. Oh, wait. MA and MG seem like they're the same ray. That's kind of interesting. So there are some times that we can name things differently, but they actually mean the same thing. That's kind of weird. And I have all kinds of different variations that I could play with that to name things in some different ways. All right, naming some lines here. I'm going to start different. I'm going to go with the line that goes through this plane, and we're going to call that line IG. And we could also call that GI if you wanted to. I could also call the one that's in the plane by several different names, so let's take a look at that. We're going to call this first line AM. Or maybe GM, because that's using 2 points on the line, or maybe even MG. And those two mean the same thing. Another way we could call that would be L, because that's the lowercase letter that's assigned to that. Cool. So if we're then talking about naming a plane, we name this either by a letter or by 3 points in the plane. So plane T would be the same as plane, I just spelled that plane, that's fun, plane EAM, because all three of those are in the same plane as T. However, we're not trying to actually do that. What we're trying to do here is to name a plane using 3 points that are not the same as T. All right, so not the same plane as T means that we have to use a point that's not on T. That means we're going to have to use this point out here. And I can use any other 2 points that I want because that will not end up being the same thing. So if we're talking about a plane that's not the same plane as T, that might be like, I don't know, E and I and M. Those are 3 points that are going to define a plane that does not include some of the other points that are in T.